You had to, a golfer was hitting a ball at 133 feet per second at an angle of 36 degrees from the horizontal. Okay, so did you get your two equations set up? Is everybody able to set the equations up? Okay. We have to, right there. I never put them away. Anybody else need one? No? Okay. Was yesterday Tuesday? I'll just stick these in. Okay. So everybody's okay with this? Now, we have no other horizontal movement. There's no wind speed. Everything's good. We have no other vertical movement. We hit the ball off the ground. And the ball went up, comes to the top, and has to come down. Whatever goes up must come down. This part right here is your gravitational pull. And that has to be there. That's what makes your ball come back down. Otherwise it would keep on sailing and sailing and never come back. Okay, so now, we're good with that? Let's put this in your calculator. Play with this a little bit. If you don't get it the first time, you'll get it. Make sure you're in degrees. Make sure you're in parametrics. If you don't set your window the right way the first time, don't worry about it. Look at your table. Something that goes in the air and comes down is not going to be gone for a very long time. Maybe 10 seconds at most here. So you're going 1 through 10. Set your table 1 through 10 and look to see where your high is and where your low is. We'll do that as well. So you enter it. Don't forget the T. If you forget the T, it's not going to work. Make sure you get both of them in, both with the T. Oh. Kind of sleepy this morning, this little board. Okay, now, because it's too hot. Okay, so I don't really know what to do with my window, so I'm just going to graph. And I got some weird looking thing here. I'm going to look at my table. I'm going to start my table at 1 and see what's going on. Probably it's taking me, look, can you tell where you hit the ground? Can you tell how many seconds before you hit the ground? What is Y when it hits the ground? Y is 0. So follow your Y. It started at 0. It's got to hit the ground. Right here. I hit the ground. So how many seconds did I take? 4 to 5 seconds. Here's your window right here. Your T, make it from 4 to 6. T, 4 to 6. X, take these X values. What's the highest X value that you see? 430. So make X go from 0 to 600, 500. It doesn't have to be exact. You just need a window. Your Y, what's the highest Y that you see? 100. So make Y go from 0 to 100, 150. You just need to see this thing turn. So if you can estimate your window, you can do it off your table. But you got to be able to work with this. Okay. So now, Isaac, you with me here? Are you on your calculator?
Yeah.
Yeah. Okay, so let's go to your window. Let's do exactly what we said. From 0 to, we said 6 seconds. Make your step 0.5. Just keep it at 0.5 right now. Your X min, 0. It's got to be 0. There's no negative time. There's no negative distance. Your X max, we said make that 600. Your Y min, 0. And your Y max, 100. You should be able to see a graph now. Just take it right off your table. It's not going to take a lot of time for whatever it is you're shooting up there to come up and come back down again. And just so go off your table. Remember when it hits the ground, Y is 0. You get enough room for your maximum height, and you can play it by ear there. You can even guesstimate what it would be ahead of time, and then just adjust your window. It doesn't matter if you make a big one or if you make a little one. When you do your checking on it, when you trace, it's still going to come out the same. So we want to trace this guy to see where it hits the ground. We're looking for, we know it was between 4 and 5 somewhere. So there's 5, I'm just below the ground. There's 4, I'm above the ground. So I'm kind of closer to 5. So here's where you need to get a little bit more detail. Set your table set to start at, say, 4.8. Let's start at 4.8. It's closer to 5. And set it by 0.001. You have to go to 3 decimals. Try to go to 3 decimals. And now look for your table. Look at your table. Look at your table. You want this Y to hit the 0. So it's not yet there. Just keep scrolling. If you found it was a long time, go back and reset your table. We'll set it to 4.9. But this isn't so bad to just scan down. You can send out a text while you're waiting. So there you go. Right there. This is where it hits the ground. It didn't hit the ground yet. There's your time. 4.866. You with me, guys? There's how far away it is from you. Scroll over and round to 3 decimals. And that's when you hit the ground. Where? How far away from you? Usually that's the part you like to know. How far is the ball from you? Now, the second part says, at a distance of 275, would 275 be the x value or the y value? X, at a distance of 275, when the ball is 275 feet away from you, there's a 9-foot fence there. Does your ball clear that fence? You're looking for x to be 275. So you have a number of ways to do this. Go back and trace and see how close this x can get to 275. Look, here's your x at 268. Here's your x at 322. Look at your y. Is it greater than 9? It's 90. So does your ball clear a 9-foot fence? By far. If you're close, then you might want to go to your table set, start it at whatever that seconds is, and start looking there to make sure it does exactly clear it at that distance. If this is so far off, you just have to show me, even if you wanted to show me this. Start your table at 3.0 and look at that if you want to get a little bit more exact. You want this to be 275. So if you want, and you want to get exactly 275, just keep scrolling. If you notice that you're so far off, go back, start your table at 2.8. It doesn't matter, just play with your table. If that's still too far, start your table at 2.7. You can't ruin anything. And we can find exactly where it is at 275. If that's too much, go do it again. It doesn't seem to like this. The other way. I can go as detailed as I want on my table. Look how close I am to 275. This is all you need to see. Right here. At 275, look how high your Y is. Your ball is 95 feet in the air. It definitely clears the 9-foot fence. Okay? If I wanted to clear a sand trap, say I'm golfing, and 300 yards down is a sand trap. I definitely don't want to hit my ball into that sand trap. I want to clear that sand trap. What would I look for? It's 300 yards away from me. What would I look for? Sand trap is 300 yards away from me, and it's 10 yards wide. What do you look for when you golf? If you're going to hit that ball? You look for the green, right? You look for the green, yes. But if it's 300 yards away from me, which distance am I looking at? My X or my Y? My X. Don't I want to see if my ball is heading through that? Don't I want to see if this is going to clear 300 and say 10? I said it was 10 yards wide. I want to see if this is going to clear 310. So let's set my table. Let's start at 3. Let's see where I am. I passed my 300. My ball is still going, isn't it? My ball is still increasing here. Look, it's on the decrease. But it's still okay. It didn't hit the ground yet, did it? And did I clear 300 yards away from me? I definitely cleared 300 yards away from me. My ball is on the coming down part now, but it didn't hit the ground. If it hit the ground, I'd be concerned. It hit the sand trap. But my ball soared right over that sand trap. So do you see what you can tell by this? This is pretty cool that you can do 3 things at the same time. You can do a vertical distance, a horizontal distance, and your time. Questions? No? All right. Let's try another one. How many of you got this? How many of you got this? That one? How many of you tried it? You're killing me. Not soon enough. We have a final to take yet. Okay, a batter hits a ball with an initial velocity of 92 feet per second and an angle of 55 degrees from the horizontal. Find the maximum height attained and the total horizontal distance traveled by the ball. I want the maximum height and the total horizontal distance. I want to see how far we hit the ball. Okay, now, again, there's no extra vertical height, so he's kind of batting off the ground here. If we gave him a vertical height, say like you hold your bat, what do you think, that's like 4 feet off the ground? Depends how tall he is, right? So approximately, would that be about 4 feet? So where would I put the +4? In the X or the Y? The Y. I'd put the +4 right here. And then you could see when you chart your ball, it's not going to make a whole lot of difference, but it's going to start here. Okay. So that's the only difference, and we should have one soon that does that. I wanted to keep the first few like kind of basic for you, so I didn't put that in there. But technically, he does stand a little higher than that. So you get your thing set up. Now, again, when you put this in your calculator, go to your table. How long is the ball going to take to hit the ground? 6 seconds maximum? No? Who knows? Can't even take that long. Look to see where your turning points are. See if you could see it on your table. Let's pull this up. If you did not do this with me now. You have to know how to do this. There's really not a lot to it. And you need this part, -16t squared. That's what makes your parabola turn. Now, let's see if this same graph works. Works for me. Do you see? Can you see? Can you trace it? I probably could spread it out a little bit more, but do I have to? No. My trace works the same way. Watch. My trace still works. It looks like it's going high and not far, but that's just because my window is a little bit different. If I want to, I can change my window. I could make my X max be a little shorter. He didn't hit the ball that far. Try it that way. Does it matter? I still can trace. I still can see it. Now your max is hard, but you want a little trick for your max? Watch. Go find this distance down here. Isn't this a symmetric because we started at the 0? So doesn't this have an axis of symmetry right where your maximum height is? So if you find, when we have to find the horizontal distance anyway, here's a little trick. Come all the way across, find the horizontal distance. So again, I'm somewhere after 4.5, before 5. It looks like I'm closer to 4.5. So maybe I'll set my table set to 4.8 again. Find where this hits the ground. calculator's a little tricky. It's magic. We're almost there. We're about to hit the ground. So right here, here's where we hit the ground, right? See us hit the ground? That's the time that you ended over here. So 4.711. Your maximum height is halfway there, isn't it? Divide this in half. So you're going to get 2.355. So somewhere your maximum height is right in the middle. It's symmetrical. You started at the 0, you ended at the 0. So if you're looking for your maximum height, this is a great one just to take the time and cut it in half. So let's call this, here's our time where our ball traveled. There's the horizontal distance that it traveled. Okay? That's how long it took. Now let's find your maximum height. I'm going to take this, I'm going to set my table to 2.35 and let it go from here. Now, what you're looking for is for this guy over here. Increase, 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 stop, and start decreasing. Now what happens is your calculator rounds. You're not going to see it exactly until you go here. I'm okay with that though. If you spot like a whole bunch of the same things in here, if here's where I'm going, you can see it increased here. It's still increasing, and after this it's going to start decreasing after the 4 ones. See it decrease again? Just go halfway into your 4 ones. I'm fine with that. So if you want to take this time, 2.357, 2.355, that's close enough. You see what I'm saying? It's so close in this part here that they're all rounding to the same 7.41. But if you look here, you can actually see the difference. See it? It changes here, but it all rounds to the same 7.41. So there's your vertical height, 88.741. Give me one of those times. I'm fine with that. Okay? This is a tough proof. Okay. All right, let's see what else we got. I'll give you the easy ones, not the hard ones. God bless you. Okay, go to number 6. 2 balls was nice, but you'll drive me crazy on that. Nobody will work with me. Okay. Alright. A Major League ball player hits a fastball with an initial velocity of 103 feet per second on a path 300 feet from the home run fence. The fence is 300 feet away from him or her. The fence is 10 feet high. Draw a complete graph of the problem situation and determine if it's a home run. It has to clear the fence to be a home run, right? Yeah. Not only does it have to make the horizontal distance, it has to make the vertical. If you watch baseball, if it hits the fence, not a home run. So we assume that gravity is the only force affecting the ball. So the ball is hit at an angle of 43 degrees. So let's see if we can do this. Here's your person hitting the ball. Let's make your person be 4 feet off the ground. He's up here when he hits this ball. Well, because he's got to stand with the bat, right? So let's say it's 4 feet high. Your crabs down pretty low for a small strike zone, so he's about 4 feet high. His body. So let's set up your equations. What's my x equation? 103 t
cosine
43. From here, he hit it at an angle. I gave it to you afterwards. I kind of used this little scenario and changed it around a little bit. I added a little wind speed and stuff like that. We hit the ball and then we added some wind speed to it. But we're going to keep him 4 feet off the ground. So is this okay so far? Okay. What's my Y? Plus 4 minus 16t squared. We need this because this is your gravitational pull. And a plus 4? Yes, you can put it anywhere. You can put it anywhere. But it has to be on the Y equation. Okay, so let's put this in. The wind speed is the second part. I want to do it without the wind speed first. And then we'll throw in the wind speed. Okay, everybody grab this. Grab your calc. We're putting this in. All right. So we're 103. See, make sure you put your T in. Without T, it's not going to work. Your plus 4, like Jessica said, can go either place. Either place you want it. Before the 16 or after the 16, it doesn't matter. It's not going to affect that. So we're going to graph. I get a graph, I'm okay. My table from before was pretty good. We had a batter before, so they're pretty much in the same ballpark. See the 4 feet off the ground? See the 4 feet off the ground? He's standing 4 feet off the ground. He's not flush to the ground hitting that ball anymore. He's actually really bad. Okay, so we want to know if he gets a home run. We want to know if, what do we want to know? You tell me. Did he clear the fence and what else? How many feet did he have to hit this ball to get the home run? 301 feet, after 300 feet. And at 300 feet, there's a 10-foot fence. So we're going to look, we're going to trace until we find an X of 300. And we want to make sure we didn't hit the ground yet. So look, here's his ball. Still in the air. See it in the air? It's still going. He makes the yards horizontally. Does he clear the fence? How did you know that? Because the Y would be 10, and now our Y is what? 28. So, yes, he clears the fence. We can say this. When time is 4, the X is 301 point something, and my Y is 28.983 feet. So, clearly, he hits a home run. Does everybody see why? Pretty good, right? I bet you didn't think you could figure all this out before this. Okay, now, we're going to change this slightly. The second part of this says he hits at an angle of 41 degrees, but there's a 22-foot per second wind blowing in the same direction. The wind was like 8 miles an hour or something, but I converted it to feet. Because what happens when they give you a wind, if your wind is blowing at 10 miles an hour, your velocity is in feet per second. So you have to convert to feet per second. Not a big deal. There's 5,280 feet in a mile, and there's 60 minutes in an hour, 60 seconds in a minute. You can do a conversion. So to save you that problem so that that's not what we were focused on, I converted it to feet. Normally you don't see wind speed in feet, but I didn't want that to make anybody be, upset about that. So I wanted you to focus on what the wind speed does. Okay? So we have to change this slightly. Let's see what we're going to change it to. Let me just shrink this down a second. We're also going to make him still stand 4 feet off the ground. We're going to change this, and we're going to add this. It's blowing in the same direction. So does that mean his ball will go further, or his ball will not go as far? Further. The wind is behind him. The wind is moving with him. It's going to move his ball a little further. If he hit a home run before, should he still hit a home run? He should still hit a home run. Then we're going to blow it in the opposite direction. So here's our X. What's going to change? We're still 103. Were we 103? Here's your cosine. This is changing. Okay, here's your Y. Okay. We're 4 feet off the ground. So here, this is where we were. We just changed our angle. Where do I put my 22 feet per second? In the X. X, not the sine, the cosine guy. Because it's going to change a horizontal distance. So it's going to add to this. And you have to put the T. Because it is a function of time. It's moving 22 feet per second. Just like your velocity moved 103 feet per second. So because time is your parameter, it has to go with the time. You good with this? Mm-hmm. Okay, so let's pull up your calc. Our window should still be fine. We're just changing your 43 to 41. We're coming out here and we're going to add a wind speed. Remember, I just converted it to feet per second for you, but it normally gives it in miles per hour. And the rest should be the same. We're going to still leave him 4 feet off the ground, holding his bat, so he's not golfing his ball. And we're going to, wow, what happened to it? I didn't change the window. What did the wind speed cause it to do? Go further. It went further. So he hit a ball pretty far. If I wanted to see exactly how far he hit it, I would have to expand this. What am I going to have to change, my X max or my Y max? X max. What should I change my X max to? 500. Don't bother with the little pieces, just like double it, add a little more, just until you can see it. Now when I trace, remember when he hit the ball, it was what, 4.5 seconds away? Now look where it is when he's 300 feet away. It's a little over 3 seconds. Do you see what the wind speed did to him? It really propelled his ball. Now let's take that wind speed and put that wind speed against him. How am I going to put that wind speed against him? Subtract. Good. Let's come to this and make it a subtract. So let's come in here. We change our X. Now the wind's going to hold up this ball, right? You think it's still going to go over? Oh, maybe not. It's a pretty big wind speed. So let's see. He needs to clear 300 up. His ball's coming down here. Uh-oh. Yeah, look at it. Look what happened. Look where he is now. He hit the ground. His ball hit the ground. His ball, look, we didn't change your window. Look what it did to the arc of your parabola. It made it higher. What happened to the ball? The ball got held up, didn't it? The wind went against it, held the ball up, and hit the ground. Didn't reach the fence. Didn't even reach the 300 mark. That's a pretty big wind speed for that. I forget what it was. It was probably like an 8-mile-an-hour wind. It was a pretty good wind. I could figure it out. I could work it backwards, but it was a pretty good wind speed. So do you see what the wind at your back does versus the wind in front of you does? Right? Questions on any of this? Are you kind of getting the hang of it? Go ahead. Questions?